Okay, so let's go over a couple at least of your homework questions from the weekend. The first one was probably the toughest one on the sheet, or at least the hardest of the first four. So it says you start from rest, go a distance of 105 meters, and end up at rest once again, and all of this in a minimum time. Okay, so you're going to have two sections. The speeding up section, and then the slowing down. So in the speeding up section, VI is 0. And it says it has a maximum acceleration of 7.5 meters per second squared. In the slowing down section, we don't know what the VI is. But whatever it is, it's the same as what the VF of the first section was. So that's what's connecting these two sections. The A of the slowing down section is negative 10 meters per second squared. And we know the VF of this section is 0. Okay? And so the question wants you to find what's delta D1, what's delta D2, how long, what was the maximum speed reached. Now, so we know that D1 plus D2 is equal to 105 meters. The thing is, this time, you probably don't want to use delta D is equal to VI delta T plus 1/2 A delta T squared. You don't want to use this equation because then you're going to introduce a whole bunch of other unknowns because we know nothing about the time. This time we know something about the VFs, which we don't usually know. So this time we probably want to use VF squared is equal to VI squared plus 2A delta D. So you could do it for D1, and for D1 the VI squared is 0, and so you would have a delta D1 is equal to VF1 squared over 2A1. And then you would do the same thing for D2. VF squared is equal to VI squared, and this is for 2, plus 2A2 delta D2. It's the VF squared that's 0 this time. So the delta D2 will be equal to negative VI squared over 2A2. So now we can take both of these and fill them in here. So where D1 is, we can write VF1 squared over 2A1. And where D2 is, we can write plus, but it's really a minus, VI squared 2 over 2A2 is equal to 105 meters. Now the thing that's important is this part. The VF1 is the same as the VI1, so I can actually just write it as V squared over 2A, pull this minus out here, V squared over 2A. But if you write it just like that, you might say, oh, it's going to be 0. No, this is A1 and this is A2. They are not the same. So I would probably get a common denominator. And to get a common denominator, or get rid of my fraction, I'd probably multiply by 2A1A2. Everything by it, including this side. Okay, so when I multiply the first term by 2A1A2, the 2 and A1 cancel out, and I'm left with A2V squared. When I multiply the second term by 2A1A2, the 2A2 cancels out, I'm left with A1V squared. And on this side, I have 105 meters to A1A2. What is it I don't know? I don't know V, so pull it out. And so it becomes A2 minus A1 is equal to 105 meters to A1A2. Now divide both sides by the bracket. So V squared is equal to 105 meters to A1A2 over A2 minus A1. Now fill in your numbers. 105 meters to A1 was 7.5 meters per second squared, and A2 was negative 10 meters per second squared over negative 10 meters per second squared minus 7.5 meters per second squared. Don't panic that you're going to have negatives. You're going to have a negative on the top and the bottom. So 105 times 2 is 210. And then 210 times 7.5 times a negative 10 is going to give you, oh, did I just screw that up? 210 times 7.5. Oh, no, I didn't. Times a negative 10 is going to give you negative 15,750. On the top, units will be meters, meters, meters. Wow. So meters cubed over seconds to the fourth. And on the bottom, negative 17.5 meters per second squared. So 1 meter and a second squared will cancel out. We'll be left with meters squared per second squared. So, oh, and the negatives will disappear. So divide by 1750. You get a beautiful 900 meters squared per second squared. Take the square root and get V is equal to 30 meters per second. Once you have that, then you can go back and fill it in for the delta D's, because I think it asks you speed and the times. So once you have this, then the rest are easy to find. So I'll leave that as an exercise for you to find. The second one, the hardest part in the second one, is reading the whole question, because it's all this gobbledygook about falling and driving into a wall. So it says you should picture yourself falling from a certain height face first onto a hard floor, because that's essentially what will happen if you're going to crash without a seatbelt. The car will smash into whatever it's colliding and essentially stop. Your body, meanwhile, will have nothing to restrain it and will keep moving 56 kilometers per hour until you smash into the dash. Okay, so it wants to know from what height would you have to fall so that you hit the ground. So you're falling. VI is 0. A must be 9.81 meters per second squared. And you want your VF to be 56 kilometers per hour, which when you change that to meters per second is maybe 15.5, but I might have just screwed up. 56 divided by 3.6. Yeah, 15.5 repeating meters per second, and it wants to know the height. That's it, one step. VF squared is equal to VI squared plus 2A delta D, solving for delta D. Delta D is equal to VI goes to 0, VF squared over 2A. Everything is going down, so we do not need to put it in as a negative. Don't forget to square that 15.5 and then divide it by 19.62. Whoops, close the bracket. So squared divide by 19.62, and you get maybe 12.33 is the height. So 56 kilometers per hour really doesn't seem very fast when you're going down Main Street. Sometimes it seems so slow that you think, man, I could walk faster than this. But 12.33 meters is quite high. The roof of the library outside our classroom window is not quite 10 meters. So falling from that roof and hitting the ground is going to hurt. So even though 56 kilometers per hour doesn't seem very fast, it is going to hurt if you run into something going that speed. Number 3, bike A, bike B. A says it has a lead of 227.27 meters and has 1,600 meters to go. So for delta B, for A, it has 1,600 meters to go. B must have then 1827 because it has that extra bit. He maintains a constant speed of 8 meters per second. VF, 8 meters per second. What speed does B have to travel to catch him right at the line? So do VAV equals delta D over delta T, solve for time. So, oops, delta D over V